Okay, let's dive into one of the biggest revolutions happening in modern health right now, the rise of machine learning in medicine. And forget the sci-fi stuff for a minute. We're going to break down how this new digital partner is already changing, well, pretty much everything, from your local doctor's office to the most advanced research labs on the planet. You know, every single day, our healthcare system creates just a tidal wave of data. I mean, think about it. Every single doctor's note, every lab result, every x-ray, and yeah, even the data from that fitness tracker on your wrist. It's a literal ocean of information, and for the longest time, we've only been able to skim the surface. For so long, using all that data in a meaningful way felt, well, almost impossible. But what if that could change? What if we could actually find the hidden patterns inside all that noise? You know, the subtle signals that can predict not just what's wrong with us today, but what might happen to our health tomorrow. That right there, that is the incredible promise of machine learning. Now, it's really easy to picture this sci-fi future full of robot doctors, but that's not the real story here. See, this revolution isn't about replacement. It's all about partnership. It's about giving human doctors a tool that can see things, patterns that are just beyond the limits of what a human mind can perceive.
This quote really just nails it. The goal isn't to get rid of doctors, it's to augment them, to make them better. Imagine combining the incredible skill and empathy of a human physician with the pure analytical horsepower of a machine that never ever gets tired. That's the future we're actually aiming for.
So, how does a machine actually learn? It sounds super complex, I know, but the basic ideas are actually pretty straightforward. So let's open up the machine's toolbox and take a look inside.
All right, first up is the one you'll see most often, supervised learning. This is where you feed the machine a giant data set that's already been labeled by human experts. So, for example, you'd show it thousands of medical images, and each one is already tagged as either cancerous or not cancerous. A perfect way to think about this is like studying with flashcards. The question, the image, is on the front, and the correct answer, the diagnosis, is on the back. After seeing thousands and thousands of these, the student, or in this case, the algorithm, starts to recognize the patterns. Eventually, it gets so good it can make accurate predictions on new flashcards it's never seen before. But what happens if you don't have all that perfectly labeled data? Well, that's where unsupervised learning comes in. With this, you give the algorithm a massive, messy pile of data, and you just ask it one thing. Find the patterns, group the similar things together, and it can end up discovering connections that no human ever even thought to look for. It's kind of like being handed a giant bin of mixed-up Legos and just sorting them into piles by color, by size, and by shape, all without an instruction manual. In medicine, this could mean finding entirely new subtypes of a disease just by grouping patients who share subtle characteristics that we never noticed before. And finally, we've got the heavyweight champion of the group, deep learning. Think of this like a whole team of specialists working together. The first one looks for basic clues, like edges and colors. The next one looks for shapes. The next looks for objects. By analyzing data in all these different layers, deep learning has become unbelievably powerful, especially for understanding really complex images, like medical scans. Okay, that's enough theory. Let's look at how these tools are actually moving out of the research lab and into the clinic and are already being used to save lives today. And the applications are just incredibly broad. You've got deep learning helping radiologists read medical scans with way more accuracy. Then you've got other models that are just dramatically speeding up the hunt for new drugs. And in hospitals, predictive analytics can now help pinpoint which patients are at risk of getting sick, sometimes before they even show any symptoms.
Let's look at a really concrete example that is just so powerful. Diabetic retinopathy. It's a leading cause of blindness. Well, now there are AI systems that can analyze a simple photo of the back of the eye and detect the disease with an accuracy that rivals a trained specialist. For people living in remote areas without easy access to doctors, this is a total game changer. It enables early detection that literally saves people's sight.
Another huge area is drug discovery. I mean, traditionally, it takes over a decade and literally billions of dollars to bring one new drug to market. Machine learning is poised to change that by rapidly analyzing millions of molecules to predict which ones might actually work. It could dramatically shorten that timeline and get new cures to us faster and cheaper.
But all of this incredible power doesn't come without some serious responsibility. With any technology this transformative, we absolutely have to stop and ask some very, very hard questions.
One of the biggest challenges is what people call the black box problem. See, sometimes a really powerful deep learning model can give you an incredibly accurate answer, but we can't fully understand how it got there.
And in a field where lives are on the line, that lack of transparency, well, it's a major hurdle for building trust.
And then there's the critical issue of the data itself. You see, an AI is only as good as the information it learns from. So if its training data doesn't accurately represent the whole population, the model might not work as well for certain groups of people. It's a massive challenge to make sure these tools are helping everyone, not just worsening the health gaps that already exist.
And this brings us to this huge ethical and legal gray area. If an AI-assisted diagnosis turns out to be wrong, who's at fault? Is it the doctor who trusted the recommendation? Is it the company that wrote the software? The hospital that bought the system? We just don't have easy answers to these questions yet.
So, with all these challenges, what does the future actually look like? Well, the consensus is pretty clear. It's not about man versus machine. It's about creating a powerful new kind of partnership.
And here's what that ideal collaboration really looks like. The AI handles the heavy lifting, the data-intensive work, finding those tiny patterns that a human might miss. And that frees up the doctor to provide the irreplaceable human element. Understanding a patient's whole life context, making those tough ethical judgments, and delivering compassionate, empathetic care. It's a true partnership.
At the end of the day, the success of this technology isn't going to be measured by how smart the algorithms are. It's going to be measured by our wisdom and how we use them. Success means putting responsibility, fairness, and above all, the patient, at the very center of this revolution.
And that really leaves us with the ultimate question, doesn't it? This technology, it's not science fiction anymore. It's here. And as it weaves itself into the very fabric of our healthcare, the challenge for all of us, as patients, as doctors, as developers, it's to guide it, to shape it, and to make sure it fulfills its incredible promise for every single one of us.